Hello everyone. Today we'll be presenting our data analysis project focused on mobile phone specifications. Our main objective for this project was to develop a robust and user-centric data analysis program. The goal was to help users explore mobile phone specifications through detailed filtering, comparisons, and range-based analysis. Essentially, we wanted to make it easier for users to understand the data and make informed decisions. Our core deliverable was a system built around five functional modules. Each module plays a specific role in guiding users, whether that's comparing products, filtering through specs, identifying ranges, or visualizing patterns. Together, these modules form a complete decision support tool for mobile phone selection. To build this program, we relied on Python. We used pandas for data handling and cleaning, NumPy for numerical efficiency, Plotly Express to create interactive, easy to understand visuals, and IPY widgets to add dynamic user input features. These technologies help make the tool both powerful and user friendly. Our dataset was mobilephoneprice.csv, which includes features like brand, model, price, storage, capacity, screen size, and battery capacity. Before any analysis, we had to prepare the data so that it was usable and consistent. One of our biggest initial challenges was data cleaning. Columns like storage and price had inconsistent formats. To fix this, we created a cleaning function to standardize storage into X gigabytes, and we removed symbols and commas from price values so they could be converted into numeric types. This cleaning step was critical because without accurate numeric data, our comparisons and visualizations would not work.
For the functions, the first one is a function that helps to clean the storage column. So we have noticed that in storage column, the value inside are in different format. So the goal is to convert the repetitive format of the same values. For example, there are values with space and without space and also without units. So we have written a function that helps to convert all of these. This is the result. So when we run a dataset.unique, and these are the formats after being used by the function. For our next function is a function that helps to compare the price of two phone models. So the goal is to allow users to compare a price of a selected model conveniently. We've made a code that define a function of compare price and compare the price of model that we select. So we add a IPY widget library and to make a drop down for the user to choose the model, and then the result will be differ. As you can see, by changing the selected model, the result will be changed, and it requires a data from the database that we use. And for the third one is function that helps to filter the data by brand and screen size. So this allows users to isolate a subset of phones based on brand and physical size. And the code behind that use not only IPY widgets library, but also a display library. So from here, you can see that we have made a code that requires a minimum size and maximum size. We also makes a drop down that use a brand as an option, and also add a range slider to add a minimum and maximum value and set a step to 0.1. So this is the outcome of this function. So it screens out all of the other brand and also the screen size that excluded from the range we input.
For function 4, this function is used to show how phone prices are distributed across different brands. It first cleaned the price data by removing symbols like the dollar sign and commas, then convert it into numeric values. After that, we create a box plot to visualize the price range and variation for each brand. Finally, it calculates summary statistics like the median, mean, and the standard deviation, which help us to understand average price and how consistent each brand pricing is. And this is our output. For the last function, function 5, this function is used to compare the relationship between battery capacity and price for each brand. Firstly, we clean the price data and convert it into numeric values, then create scatter plot showing battery capacity against price. The axes are kept consistent across all brands so we can easily compare them. Moreover, these help us identify pricing trend and see which brand offer better values for the same battery capacity. This is the example of our output.
The project was evaluated based on the criteria for completeness, difficulty, and code quality as per the project rubric. Starting with project completeness, I'm claiming the maximum score of 10 out of 10 points. My justification is straightforward. The project fully meets all 5 functional requirements outlined in the objective. Specifically, first, we implemented the filter by brand and screen size feature using our filter by brand and screen function, seamlessly integrated with IPY widgets for a dynamic user input. Second, the compare two models requirement is met by the compare price function, also utilizing interactive widgets. Third, we visualized storage against other metrics using a clear plotty scatter plot. Fourth, we provided a detailed price distribution analysis through an interactive plotty box plot and summary statistics. And finally, the fifth requirement, battery and price comparison, is implemented with our plot or battery price by brand function, ensuring we use consistent ACEs for meaningful comparison. Moving on to project difficulty, I'm claiming the maximum 5 out of 5 points. I believe this project goes significantly beyond simple data querying by incorporating several advanced techniques. First, we tackle complex data processing. The raw data was messy, requiring custom functions like clean size to transform difficult string format like 1 TB into usable numerical data. Second, we use advanced visualization by leveraging Plotting Express. This didn't just create standard charts, we implemented custom logics to ensure consistent scaling across multiple plots, which is a key requirement for valid data comparison, specifically for the function 5. Third, the integration of the IPY widget library provided a truly interactive input. This creates a far more dynamic and user-friendly experience than static analysis. Finally, the code quality and appropriateness. I'm claiming the maximum 5 out of 5 points. This score is justified by focusing on best practice in 3 key areas. The coding exhibits strong structure and modularity. It is highly organized in single-purpose functions, for example, compare price and price distribution, which makes it easy to read, test, and maintain. We followed established best practice, making proper use of the pandas library for vectorizing operations like efficient Boolean masking and including dedicated Python docstring for, for enhanced readability throughout the code. Crucially, the code is robust. It includes necessary data type conversations using functions like type and PD point to numeric, and we proactively implemented error handling techniques such as the error correct argument and try except blocks to prevent crash when dealing with expected or bad data. So in summary, the project delivers a complete and robust solution, earning the full 20 points across all three evaluation criteria.
Also, we would like to formally declare that this project is our own work. All code written in this Colab was developed by us to meet the functional requirements of the assignment. During development, we use AI tools and official documentation as supportive resources. Google Gemini in Colab was employed to generate the initial project objective statement, help structure the report in line with academic standards, and to assist with complex syntax for data cleaning tasks. And official Pandas, Plotly, and IPY widgets documentation was consulted to ensure correct usage of advanced features.
The project successfully transformed raw, messy data into an intuitive, interactive, analytical tool, demonstrating proficiency in data manipulation, visualization, and user interface design using the Python ecosystem. Thank you.